CIT 1122 instructional video for Packet Tracer 3.2.8. In this particular video, we've got a topology of three switches that are connected linearly, and each one of those switches has three PCs connected, each PC in a different subnet and in a different VLAN. So they've set the ports up so that devices on VLAN 10 will be in the subnet 172.17.10.0/24. Devices that are in VLAN 20 here and here, so that's 2 and 8 and 5 are in subnet 172.17.20.0/24. And devices that are connected to VLAN 30 are in a different subnet 172.17.30.0/24. And you can see that's PC 3 and 9 and 6 are all in VLAN 30. So we've got three subnets, and these three subnets have three PCs each. And so the PCs that are in the same subnets and the same VLAN should be able to configure, should be able to ping each other. And that's really the goal of what we're going to look at here is how these switches control these broadcast messages between different devices. So let's go ahead and we'll start with that. So right here at part 1, we're going to observe some broadcast messages, and we want to ping from PC1 to PC6. So PC1 is here, and PC6 is down here. PC1 is in VLAN 10, and PC6 is in VLAN 30. Now, if that's going to happen, here's how this plays out. PC1 wants to communicate with PC6. PC1 knows that PC6's IP address is not in the same subnet as PC1. So if we open up and look at PC1 and we just do a quick config here, do an IP config. PC1's IP address is 172.17.10.21. PC6's IP address is 172.17.30.26. Two separate networks. So what PC1's job would be to do this. It would be to send out an ARP broadcast message for 172.17.10.1 to get the MAC address of the default gateway that would then route the traffic to a different network, because we're starting on one network, the 10 network, and we're going to the 30 network. And the only way we're going to do that is through a router. So what we need is the MAC address of the default gateway. And there is no default gateway in this diagram. So this is not going to work. When we go to ping between PC1 and PC6, this is going to fail. Let's give it a shot. So we do a ping. We'll go 172.17.30.26. And we're not getting anything back. Okay, good. So let's watch this through the simulation mode. So in the lab, they say, okay, let's go to simulation mode. So we're going to go to simulation mode here. And then we're going to click the simple PDU, add simple PDU. We're going to click on that, and we're going to go to PC1, right? So we're going to click on PC1, and then we're going to click on PC6. And then that's going to set it up, and then we're going to watch it go. So simulation tab. Simple tool, click PC1, click PC6, start and end, beginning and end, whatever. And click the capture forward button to watch the ARP transaction. So we're going to be watching some ARPing. So we're going to click forwarding here, and that hits our switch 2. Now, switch 2 is going to forward this broadcast to any interface that's in VLAN 10, which is no other interfaces. But interface 1 right here, is set as a trunk. So this ARP will go to switch 2. We'll go to switch 1, excuse me, from switch 2 to switch 1. Let's click on that, and that's the only place that it goes. Now, stopping there, seems pretty good. The ARP request is going to go to any interface that is configured for VLAN 10 or a trunk. So let's click next, and that just happened. So PC7 receives it and says, I'm not the default gateway. Thanks, I'm throwing that away. Switch 3 receives it, and it says, let me look at my port groups and find anything that's in VLAN 10. And it then forwards it to PC4, who checks its IP address and says, no, that's not me either. And we're game over at this point, and we could do it again, and it's not going to make a difference. So we've seen what happens there is the ARP has failed, right? So we can't get from point A to point B because we don't have a router in place. The buffer full has just shown up, and we'll say view previous event as it says here. And we're basically ready to now move down to step 2, which is ping PC1 to PC4. Okay, so PC1 to PC4, they're both in VLAN 10. If we were to do that, would this work? PC4's address is 172.17.10.24. So do a ping 172.17.10.24. Should this work? Yeah, it should work. This should be successful. Oh, it's because I'm not in real time. Sorry. I'm like, oh no, it's not working. So I just had to switch that back. And there you see that it did actually work that time, because that ARP broadcast message in this case is not going to the default gateway. It's going to the actual destination because they're in the same subnet. So PC1 sends out a request, says, who is 172.17.10.24? PC4 receives it, as does PC7. PC7 disregards. PC4 says, that's me, and it sends back its MAC address, which allows PC1 to create a full ICMP PDU and send its request over to it, and it bounces back, and you get the replies, and everybody's happy. So that gets us through really step 2 there. And then step 3, it says, well, hey, you know what we should do? Let's just clear all this out and have no configurations on these switches, and then see what happens. So, okay, seems fine to me. So let's go to switch 2. Let's go ahead, and this is a nice, it's kind of a, it's not the best way to maybe get to this, but it does show you if you wanted to clear a switch, you do get those skills right here. So when you clear a switch, it's a little different than clearing a router. Number one, you do an erase startup config. That's fine. Second thing, you also have to delete the VLAN database. If you don't delete the VLAN database, the VLANs will still be there. So we're going to go ahead and clear those as well. And now this switch is clear. We do a reload. And that one's reloading. So switch 2 is done. Let's do the same thing on switches 1 and 3. Whoops, that's not going to be good. There, that's a little better. And reload this guy. And let's go to switch 3, and let's do the same thing. And reload there. And this is a good place where we can hit the fast forward button. And everything should go up into place. And there's a little problem with packet tracer. You want to make sure, I've noticed this a couple times, as when I go through these videos, I do them usually once or twice, and I think about what I want to say, and then I write some notes down, blah, blah, blah. And I've noticed that sometimes when I do the reload, the link between switch 1 and switch 3 just doesn't work. And packet tracer is an awesome tool, and it's really, really great. But every once in a while, it does flake out a little bit, and you end up with a disconnection between switch 1 and switch 3, which shouldn't be. It should be reconnected. So at this point, when we look at any of the configs on any one of these switches, what you're going to see is there is nothing here, right? All of the interfaces that were configured before are no longer configured. And now we can go back and we can do this again. So we'll go back into simulation mode. And we'll go to add simple and click on PC1, and we'll go to PC6, and let's watch what happens this time. And the broadcast message goes to the switch. And even though devices 2 and 3, PC2 and PC3 are on different VLANs than, or in different subnets than PC1, this time everybody gets the broadcast because there are no port groups, there's no VLAN configuration on any of the switches. So that ARP request is going to go to everyone, and they're all going to disregard it because it's not for them, right? Will PC6 respond? No, because the ARP request isn't even for PC6, right? The idea is that there is a ping that we want to send to PC6. Great. But the way we have to send it is we have to send it to our gateway. And there is no gateway here, so it's still going to fail. Even though the broadcast is reachable, it's still going to fail. So that's a downside, right? So that really takes us through this particular lab. So if a PC in VLAN 10 sends a broadcast message, which devices receive it? Well, in the second part, all of them, right? Same thing for 2 and 3. What happens to a frame sent from a PC in VLAN 10 to a PC in VLAN 30? We just talked about that. And as far as 5 and 6, each interface is a collision domain. And at this point, in terms of broadcast domains should be limited to the same devices in the same VLAN. But now we have a disconnect here where PC1 is supposed to be in VLAN 10, but all of the interfaces on switch 2 and switch 1 and switch 3 are back to default, so they're all in VLAN 1. So these VLAN tags or values here, once we cleared everything, those should just be tossed because they're not configured as those VLANs. Every interface is VLAN 1, which means the broadcast, all you got to do is send an information out an interface, it will get there, okay?